Welcome to Get Your FRQ On. This question is from 2009. It's question 3, and it is calculator active. In the question stem, we have a cable company that manufactures and sells lengths of cable. Each meter of cable costs $120, and it costs the company 6 times the square root of X dollars for X meters of cable to be manufactured. In part A of the question, we are asked to find the profit on the sale of a 25-meter cable. All right, so profit is just revenue minus cost. Revenue would be the total money made by selling the cable. Cost is the amount it costs the company to make that cable. All right, so profit, if it's revenue minus cost, 25 meters of cable sells for 120 times $25. So the revenue part is 120 times 25. The cost is given by the integral from 0 to 25 of 6 square root x dx. It's a calculator active question. This you should be able to just plug in, and eventually you'll get $2,500 of profit on a 25-meter cable. In part B, we are asked to explain the meaning of the integral from 25 to 30 of 6 square root x dx with units. This one can be a little tricky. It's not obvious because it's not very often that you see a question test this particular skill in a free response question, although it does happen occasionally. The way we want to think of this one is to think of this like a properties of integrals problem. All right, this integral from 25 to 30 of 6 square root x dx is equal to the integral from 0 to 30 of 6 square root x dx minus the integral from 0 to 25 of 6 square root x dx. That's just a property of integrals. Now the question is, what does that difference actually mean? Well, this integral represents the total cost to make a 30-meter length of cable. This integral represents the total cost to make a 25-meter length of cable. So that difference would represent the difference in cost between making a 30-meter cable or a 25-meter cable. In part C, we are asked to write an integral for the profit on the sale of a generic K-meter cable. Well, profit, again, is revenue minus cost. So the profit from selling a K-meter length of cable is going to be the length K times the 120 that it sells for. And then the cost will just be the integral from 0 to K of 6 square root x dx. Okay. So if I set up an integral for the profit, I get 120K minus this integral from 0 to K of 6 square root x dx. Notice the 120K is not being integrated. That's because we know how much it costs to sell a K-meter length of cable. It's just 120 times however that long that cable is. That doesn't need to get integrated. All right, so part D, what is the maximum possible profit for one cable? All right, so based on the function we found in part C, the profit for an arbitrary length of cable K is given by an integral expression. P of K is 120K minus the integral from 0 to K of 6 square root x dx. Okay, we can actually evaluate the antiderivative of 6 square root x. So we're going to get 120K minus 4K to the 3 halves plus our constant C. Note, our P of K that we come up with, 120K minus 4K to the 3 halves plus C, that is continuous and differentiable for all positive values of x. Not going to worry about what happens at 0 because we're not concerned about what happens at 0 in this question. But as long as x is greater than 0, continuous, differentiable, a lot of different theorems at our disposal now. All right, so the derivative of P of K is 120 minus 6 square root K. Okay, not difficult. But if I want to maximize that possible profit, It's either going to happen at an endpoint or somewhere in between where the derivative is 0. So I need to figure out when is the derivative 0. Well, p prime of k is going to equal 0 when 120 is equal to 6 times the square root of k, which means that 20 is equal to the square root of k, so squaring both sides, k is 400 meters. So the maximum possible profit could occur at 400 meters. Now, assuming there's no limit to the length of the meter that the company can make, obviously there is practically, but there's nothing in the question that indicates that this company is bound to make cables of a maximum length. So I would assume that this is an unbounded interval. And if that's the case, there's no endpoint greater than 400. And then, what's the profit on a 0 meter cable is going to be 0. So probably not going to happen at 0 either. So there's reason to believe that the maximum profit is going to be at 400 meters. Let's show it. All right, so if we have our p function, we have our p prime function, we can find p double prime, or the second derivative of p. That's just negative 3 over the square root of k, but 3 is positive. The square root of k is going to be positive. This expression for all positive values of k is going to evaluate to a negative number, which means that our p function is concave down everywhere, which means this value at 400 has to be a maximum. It's going to be the only one. It's not going to happen at 0. There's nothing in the work that says there's going to be a bound greater than 400. Okay, so the maximum profit is just going to be the value of our p function at 400, but since this is a calculator active question, you can just plug this into your calculator. The maximum profit is $16,000.